So hello everyone, I am Alberto Planas, I'm part of the Future Technology team, and today we are going to do the third kind of presentation about full disk encryption in openSUSE. The first one was about the planification, the thing that we want to do in MicroS in Tumbleweed. The second one was the realization of this planification, and this one is about the different change that we did over the last year. Some of them is moving forward the project, and some of them is kind of lateral movement, decision that we changed, not big ones. So let's talk about that. First, a bit of context. This is a slide that we have since the first presentation, and sometimes I forget myself why we are doing this. But basically, the goal of full disk encryption, the motivation about that is about data protection. So when we lost the laptop or we discard some hard drive, we want to guarantee that the data that is stored there is not going to be accessible by anyone. But it's also about data authentication. So if somehow some attacker have access to our computer and screw the hard disk and make some offline data tampering, this is going to be detected, or at least the file system is going to refuse to load the file that has been changed. But it's also about rollback. For us, it's really important. Rollback understood as the traditional kind of attack that you make a copy of the hard disk, you wait like 1 year, discover some CVI inside the previous version of the system, and replace the current root file system with the one with the hole, and you attack that. This should be detected, but it's also the kind of rollback that we have in MicroS. So the natural operation of MicroS is to go to a very to an older snapshot. That should also be prevented in certain situations. But this is nothing about local exploits. So we have a local exploit, we have a local CVI. This is game over for us. For that, we have different tools like EMA or EVM or remote attestation that our team is also have a solution or proposals about that, for example, Keyline. We should also mention that full disk encryption is nothing new in openSUSE. We have the traditional one based on the Grad2 bootloader. This bootloader is really huge, really complicated for a different area. We have BIOS, different architectures. It's a very interesting bootloader, but with a lot of baggage. In this traditional model, we usually have a password in openSUSE. In the traditional model, this power is going to be asked 2 times, but there are workaround, very well documented workaround for that. When you change the init.rd and put the secondary key, sorry, you put the same key in the init.rd. And recently, Upstream accepted certain patches, I think from from Microsoft, and with some maintenance from SUSE and other companies about some new concept that is the key protector, that is kind of a plugin architecture when you can plug different authorization mechanisms, and one of them that has been implemented is the TPN2 support. So nowadays, Upstream Grab2, we can say that support TPN2. But we are going to talk about an alternative that is a user space full disk encryption. So the bootloader in this model is only about loading the distribution or loading the kernel and nothing else. This architecture is based on 2 concepts. One is the bootloader specification, and the other one is the systemd tools. Systemd was selected here because they have a very interesting proposal, very aligned for the stuff that we are looking for, and they are aiming to become some kind of a standard in Linux, for Linux distribution. It's compartmented in different tools that you can use as they recommend, but there are different use cases for that. You can orchestrate the tools in a different way, that this is how we are doing that, and provide a solution that is mostly unified. The nice thing is that this is a shared common base code, and every distribution has the option to review that, provide patches. We did that, and the merge cycle is extremely fast. I mean, extremely fast in comparison with Grab2, and very profitable for us. Because we are using user space tool, we have the full network stack at our disposal, better memory management, no limitation about resources. I mean, besides the obvious one, we are not talking about implementing that in the Grab bootloader, but in the user space. So that means that by default, we are going to have more authentication options. So we are talking about password recovery key, but also certificates, PKCS 11 certificates, a more complicated, more cumbersome, more enriched TPM2 support, where we can have TPM plus a PIN, a secret that the user knows. We can have different kind of policies implemented there based on traditional fixed PCR values, but also we have support from since very old time about signet policies or the new model based on MV index policy, where the TPM is storing the policy together with the secret, together with certain metadata information, like some other PIN that can be used to modify the MV index policy inside the TPM. So it's a much better solution because this is not going to require every time that we do an enrollment or re-enrollment of the system or an update of the prediction, it's not going to require any change in the different storage that we have enrolled in our system. Besides that, we have a full support for FIDO2 keys, more stuff in the queue. So one of the pillars about this architecture is the bootloader specification that was introduced by systemd-boot. Systemd-boot is a very small and simple UEFI bootloader. That means that it's leveraging all the protocols that UEFI is providing. So that means that you have by free integration with TPMs, by free you have integration with a network and other components, meaning that the code that is about the bootloader is a fraction of a grab, meaning that it's more secure or only because it's smaller. The bootloader specification is an open document. There is a sister document that is the bootloader interface that explains how to interact with the bootloader using some FAI variables. And basically, one of the key components here is that there is no configuration file. I mean, there is a configuration file, but it's not a script, a complicated script that is going to be executed in different contexts, like the proposal that Grab have. But it's going to be for type 1 entries. There's going to be a very small configuration file with a title, metadata, and the specification about the kernel command line, the kernel initRD that we are going to use, together with some ordering information, but nothing else, very declarative. Or type 2, that is a UKI proposal. It's completely optional. You can use that. openSUSE, the bootloader team have a proposal to integrate type 2 in openSUSE. It's very interesting. So maybe this is something for the future for us. But the good news is that this same team backported a set of patches from Fedora into the grab2, and we have now a new sub-package that is the grab2 BLS, that is a single FEI binary that contains all the theme assets, like the graphical asset, the font files, the configuration file, and everything embedded in a single FE binary that you can install in the same way that systemd-boot is installed today. And it's partially following the BLS specification and the BLI interface specification. It's a partial support, but enough for us. And this is a massive simplification for the architecture that we proposed some time ago. This is ready to be used, and we are working on making the default option for openSUSE. Something to remember, because this is, this is 2025, so TPMs are not new anymore. Most of us know about what are the TPMs. It's boring stuff nowadays. But we are going to use 3 different concepts about TPMs. TPMs are complex, provide a very rich set of features, and we are going to use one that is a measure boot, that is the process where every step of the boot process, every one of them is going to be measured by the previous step before jumping the execution to the next step. It's going to be measured, meaning that a hash is going to be calculated, and a PCR, that is an internal register that is stored inside the TPM, is going to be extended. The extension is a cryptographic operation that doesn't have a reverse. Basically, it's going to represent the state of the system in a specific moment of time. Everything is going to be measured from the beginning of the UEFI until the end of the initRD. Another feature that we're going to use is the sealing. That is, you have a password, a secret, and the TPM is going to allow you to encrypt, to protect this secret using a policy and some internal information that is inside the TPM. There is Each TPM have some cryptographic key that is unique for them, that cannot be exported, and there are other keys that can be reset by the user that can invalidate everything that has been signed or encrypted by this TPM in any moment of time. And we can write policies that is like a logical expression that is going to encrypt or disencrypt this secret based on the status of different PCR values or user input or any external component like a smart card or FIDO key input. So that means that this secret cannot be sealed even if you meet the policy in a different machine than the one that was used for sealing the secret. And the last component that we are going to use from the TPM is the event log. That is basically a register in memory that contains all the extension that has been done during the boot process. This register contains every entry contains the data that you expect, that is which register has been extended, using which hash value, and for what reason was extended. So some kind of metadata and description. This architecture was proposed in the first presentation, was implemented in the second one, and is still valid in the third one, so in this one. So we didn't move from this model. Basically, it's the traditional openSUSE microOS installation that we really know where the root file system is storing Btrfs. Below the file system, we have a LUX2 device, but the kernel and the initrd are outside the root file system, are in the FAT32 ESP partition, so are in the clear. They are measured, but they are in the clear. Using this architecture, we can guarantee that the full measure boot situation is happening. Everything is going to be measured. That means that in this situation, secure boot and measure boot can be combined or one selected before the other. So at the end, that means that if measure boot is in place, we can create a policy, and the initrd is going to be able to open the LUX2 device for the root file system using the TPM. The TPM2 is the policy applies that is going to decrypt the LUX2 password and is going to mount the device, and the switch root can happen. So this is still valid, and this is still valid today. For that, we are going to use a set of tools. System D is going to be considered the low level here, and we are going to use the expected tool. So System D crypt setup in order to mount the device and to open the secret and to make sure that the policies are all in place, are okay. System D crypt enroll to enroll devices. You can have more than one device, more than one partition that is going to be encrypted and going to be open during the initrd or after the switch root. It's on your choice. You can use crypttab to choose when this is going to be open. And for the generation of prediction, we have the systemd tool, that is systemd PCR log. That this is the tool that is going to generate NV index prediction. But because NV index is kind of new, there are old revision of TPMs that today are not supporting the NV index policies. For that, we are providing like a fallback that we hope to eventually fade out based on SIGNET policies. That is PCR Oracle, is a tool developed here in SUSE, and we are maintaining that. There is still work to be done in PCR Oracle to be aligned completely with Graph2 BLS, but we are moving there. From that, we have this encryption tool. That is a tool that is going to do online encryption for image-based distribution. This has very nice properties that we can talk later, but it's not required for the normal operation. We have a dark PCR signature that is like a workaround for certain limitation that we have because we are using type 1 boot entries. With UKI, this service is not needed, but today we're not using that. So we are going to use this component, this service, to copy some information that is stored in the ESP inside the initrd that is in memory that contains certain information that is required during the opening of the LUX2 device. And the big one is STBit util, that from one side is taking care of all the BLS integration in openSUSE. So it's the one that is synchronizing the kernel installed in one snapshot and making sure that this same kernel is stored in the ESP. Also, when the bootloader updates, make sure that the synchronization is happening and the boot entries are created in a consistent way. But also it's taking care, because it's kind of natural, about all the full disk encryption small operations that are going to orchestrate the low-level stuff that we are going to use for full disk encryption from systemd. So that means that the boot process exposed in the last presentation is still valid. It's mostly the same, but with some small extensions. Basically, the extension is because we find an attack vector that can be resolved introducing a new service in the initRD, but by the rest is exactly the same. So it's what you expect. So you have the firmware that is doing the measure boot, initiating the measure boot process. Sometime in the future, it's going to reach the bootloader that can be grab, BLS, or systemd boot. It doesn't matter if it's following BLS. It doesn't matter what the bootloader is, and eventually the bootloader is going to load a boot entry selected by the user or is marked by default in some F variable, and this boot entry is going to contain the kernel, the initRD, and the command line. The command line is the one that is going to select the snapshot that is going to be used as a root file system. If the measure boot process worked properly, system decrypt setup is going to open the Lux device using the data that was missing in the initRD in memory, but was delivered by PCR signature, the dragcode component. And at the end, some new service that we can check later is going to do a last check before the switch root happens. And the workflow that was proposed at the beginning of the presentation, sorry, like several years ago, and the last year is still valid. So zippered up or actions that are going to change by one side the bootloader configuration or the full disk encryption predictions are going to be triggered automatically by the Snapper plugins or the SUSE module tools, and nowadays also by the Toolkit plugins. So basically, they are working together to orchestrate and decide when systemd boot needs to be called. That is going to realize the operation required for BLS, for example, creating a new boot entry or updating the kernel or whatever is required. And then it's going to decide, okay, this change is going to invalidate the predictions. So let's update the predictions now and generate a new file in the ESP that is going to contain the values that are going to be used for the next boot. That is going to validate a subset of the option that the user have for the next boot. So what we changed during the last year? I think that the biggest change in terms of usability is that now the enrollment process is part of the STButil tool. This is kind of obvious. Well, I mean, why so late? And the reason is that we started developing the tool as a disk image distribution. So we are talking about QEMU image that can be booted. So there is this tool, Disk Encryption tool, that is doing the online encryption, and together with the online encryption was also doing the enrollment. This mistake was fixed now, very early, and now we have the enrollment and enrollment in the correct place. That means that using the command line tools, you can manually trigger the enrollment using the method that you prefer. You can select the device that you want to enroll, the PCR set that you want to enroll, so everything can be done directly from here. One nice side effect is that this is allowing you to provide a public interface about the enrollment for different kinds of installers. We have Gamma, we have Just, but we have Combustion, we have other kind of tools that like use First Boot that we should work together. And because they are executed in different moments of time, maybe the requirements are going to be different. So that means that this interface is providing different options to to deliver to SDB util the secrets that are going to be used during the enrollment. Basically, what ping is going to be used if the user select TPM and ping, what password is going to be using to unlock the device for the first time, what password is going to be used to enroll the device. So this kind of stuff is going to be delivered by several mechanisms. One of them is entering the data, the traditional one of entering the data, asking with a prompt, environment variables for debugging or very small tests. But the cool one are the using the kernel key ring. So the keyctl is a very nice way to put certain secrets, and now the kernel is going to have the ownership of this secret and is going to control who can access to that using concepts like session, users, and process. But also you can use a system credential. This is extremely cool because you can delegate the enrollment to a service that is executed in the initRD very late in the boot process. And there is this service that is going to read this credential. This credential can be only read by this service, and this service is going to transform these credentials into calls to distribute util. So that means that the enrollment process can have multiple entry points, no? Using this service or CH root calls to distribute util like is done by Jazz and Agama. Another important change that we did is PCR 15 protection. This is a kind of attack that was I think first documented by Fabian here in SUSE, and many months later was replicated by another developer, but that basically consists of replacing the looks2 device in a situation where the TPM registers are in a good state. So basically, this information, the information of the looks2 is public, so the UID of the device or the partition are public, so that means that you can replace the device. And if you have a fake initRD in this device, you are going to be able to unlock the secret because the PCR are in the correct state. Fixes for that are multiple. One of the good one is using TPM plus PIN, TPM2 plus PIN. That means that when the fake initRD is going to try to unlock the secret, a PIN is going to need to be entered by the user. So if you don't know the PIN, you can unlock the secret, we are safe. Another one is using a new property of system decrypt setup that is using in etcrypt tab a property that is named TPM2 measure PCR yes, that is going to open, is going to, once the device is open, is going to extend the PCR15 using the volume key of the Lux device. In any order that the device is open. So if you have two devices, there are going to be extension, but with an order that is not specified at the beginning. So this is very nice because you can create a policy that is going to be bind over PCR15, expecting the value 0, that is going to scramble the policy the moment that the switch root is going to happen. That means that the attack have now a status of TPM, of PCR that are not in compliance with the policy and cannot be open the secret. But this is half a problem for us. We can use this kind of solution because the TPM is also storing a ping that we need to recover in order to update the policy. And this is something that the user is going to do very frequently. Every update is going to require an update of the policy. That means that the asking the ping every time that we use we update the policy is a no-go. So for that, we create a new service that is going to be executed just before the switch root that is going to validate the status of the prediction of PCR15 alone. So the process now is that the device or devices are going to be unlocked, but before delivering the execution into those devices, a new check is going to happen. And there is also a service that is going to put order on how the devices are open, meaning that PCR15 is completely and fully predictable. Another change that we did is that this is basically making change to have a more better experience, a more secure experience with automatic updates. Basically, how PCR log works is that if there is one component, so it is parsing the event log, and if one of the hashes in the event log is not found in one of the components that we have in our system, this PCR is ignored. This is very nice. Generally, it's very nice because it makes the solution very resilient. So that means that you are going to have a protection, maybe not a full protection, but it's going to work, and eventually this is going to be covered by the next update prediction that is going to have the component in the proper place. But it's dropping the security without a proper notification to the user. The solution can be done at the SUSE util level. Basically, means that when we are going to do a new prediction, we are going to find the component or the variation that contains the hash in the event log, and we are going to keep that before removing the old prediction and updating with a new one. So this is going to be kept, and PCR log is going to make the alignment of the component inside the event log. In that regard, because the kernel and the initRD are stored in the ESP, we need maybe a bit bigger ESP of 1 gigabyte. But you can work with half of that. In microSD, this is not a problem. But in Tampered, we can have multiple kernels, making very hard the allocation of free space. So in order to avoid that the new kernel cannot be installed, we have a better algorithm that now make a smarter choice of what kernel from which snapshot is going to be removed, with the expectation that this old kernel from this other snapshot is not going to be booted frequently. In the same sense, there are some limitation about policy OR, that is a technical limitation that is only happening in Tampered because of the multi-kernel. And when we are talking about multi-kernel, it's about installing 4 or 5 different kernels in different snapshots that have a combinatorial explosion that hit a limit that is today in systemd. We resolved that, making smarter decisions. But there is a lot of small change that there is no time to discuss about that, but it's about making better choices and for multi-disk encryption, understanding the swap partition that now can be encrypted, adding new commands that are going to resolve the limitation of graph BLS in relation with the BLI, the bootloader interface, and many other more, like bash completion, auto completion, that is a very nice tool for the user. Other tools follow the same process. Now, for example, full disk encryption is a fraction of the size that you used to have. Now it's only about online encryption, and because it's not doing the enrollment, have very nice properties. One of the properties is that now it's possible to have installation without a key, so you have an installation without a password. This password is like a transient password that is going to be removed after the TPM is enrolled, if you want to have that. Eventually, we want to replace that with systemd repair, but it's still an ongoing process. In the same way, that could PCR signature have a big refactoring. This was a critical component that can break your system very easily, but with the refactor, it's now very robust, and I don't have any report of any user science a long time ago. And this is the kind of expectation about the user interface that you have now. You can enroll the device using different parameters to specify the method of enrollment, the different PCR that you are going to enroll. In the same way, you can command update predictions, and you can command also the update of this PCR 15 value that is going to require you to enter the password, because the volume key is not something that is going to be accessed by anyone. You can unenroll the system. You can query the information of the system using asking the kind of bootloader you are going to use, listing, entering, and kernels, showing values of fields of the entry. This is good for shell scripting if you have a different tool like update bootloader. I think that is the name of the new per bootloader. They are using this tooling to gather information from the system. Tool for command line for generating the initRD, and for changing the command line and updating the command line options in all the entries that we have. In the same way, you can set the timeout of the default entry. This second one, the default entry, is very interesting because it's an update in an every variable without requirement of the change of the default snapshot by snapper. So it's an alternative way of selecting a default snapshot without changing a snapper or anything in the Btrfs side. You can downgrade now the bootloader. You can clean up the boot entries and the kernel, maybe saving some space more. But most of the time, that should be completely transparent. So transactional date DAP or zipper DAP is going to call SDB util for you using these SUSE module tools or Snapper or Toolkit plugins. And in the same way, Snapper, a removal of a snapshot or setting a default one is going to you to make the proper synchronization and update of prediction in the bell size, and the same when removing a kernel. But eventually, sometimes, and I think this is good because we want to fade out this tooling, you are required to use the low-level one, for example, to check if something has been enrolled or to understand at the boot the reason of why the prediction fails. Future work is massive. I mean, there is no limit on that, or you can stop wherever you want. But the principal component that we want to fix is just the installer, so or a gamma. We want to have this experience from any user that make a fresh installation from the installer, and we want that to be tested by OpenQA. The work is in progress and very advanced in certain situations, but it's not complete. And we want to work upstream in a new authentication method that combines the measurement of the system, so we guarantee that the system is a healthy state, together with the FIDO2 key. So instead of entering a secret or entering a PIN, you are going to press a key, a button in one key. But eventually, we want to fade out the three tools: SDB util, dark code PCR signature, and this encryption tool. We want to be removed from our stack. For that, we need to upstream everything in different places. We have documentation. Please go there to read the documentation. The first one is updated, and I'm taking care of updating that. We write blog posts with different level of depth. And yeah, we really hope that people start using that, complain, create a report, and maybe you have a question.
So with this system, obviously, as well, the key needs to be released by the TPM when the policy conditions have been met. But in a scenario where, let's say, the PCRs can't be met or the firmware has updated, is there a recovery path, such as an alternate policy there? What is that recovery path? What is that?
Yeah, this is a good question. So you have different methods of authentication, no? So let me see where I listed that.
Is that alternative method of authentication, is that using the actual FDE key from an external source, or is that an external, or is that something like a recovery key that's put into the TPM and then the TPM releases?
All yes. So you can have a normal looks2 password. So you enter you have a recovery key with high entropy that was created by you. It's used in automatic installation. You can have a secondary authentication method like the FIDO key. So it's all yes.
Right. So
it's selected by you.
What I'm asking is, in the policy that you have for the TPM,
yes,
you can obviously have an OR condition.
Yes.
Is one of those OR conditions just an OR value with a recovery key?
No, the OR condition is used to select different combination of components. So for example,
right,
I am allowing you to boot this kernel or this other kernel, but not this kernel.
No, I mean in the TPM policy.
This is in the TPM policy is explained. So it's telling you this hash for PCR4 is accepted.
Okay.
So or this hash is accepted. This or is expressing to you once that the policy is created, it's expressing combination of kernel command lines that are allowed to you.
So recovery options is there's no recovery option where the key can be released from the TPM using an alternative method. It has to be something else, like a
recovery option,
binary key or a password that's stored externally.
Yes. Exactly. So it's a different kind of looks2 entry. So that means this is interesting. It's a proper decision because you can remove all the alternative option, or it's TPM or nothing. So
yeah, I think in the case where there would be only the TPM, are there considerations in the future for recovery methods that only rely on the TPM, such as using that policy, where the policy can have an auth value that can be a recovery?
But this is also covered. This is all because there is the concept of TPM recovery ping.
Yes.
This is the recovery. This is the hash that you have to replace the policy. But for that, you need to boot.
Okay, yeah.
For that, you need to boot. So there are two kinds of recovery. The one that allows you to boot to change the TPM policy,
Yeah.
and the PIN that allows you to change the policy in the TPM. So you have
Yes.
these two levels. For the first one, the TPM is not used. You use a different looks entry.
Yeah.
For the second one, yes, the TPM is used.
Yeah. With the policy as well, do you want to ask your question first? I've already had time. You ask and I'll come back. I'll give you a spot.
Oh, thank you. You said there the ESP needs to be a gigabyte, which I fully agree with. I even would to make it even larger than that. But that requires to change the default policy when partitioning the system, which is a policy change in Agama or whatever you use. Did you for a gigabyte? Okay, none of the system I installed, I do get that. Why? Okay, good, fine. The other one, have there been considerations to use TCG and TCG Opal? Not necessarily for encryption, but to set the entire drive to write protected and to write protected, because that would cover the ESP too.
Okay, I mean,
Oh,
I-
answers no, you haven't. Okay,
no,
good.
no. But I am interested in that. So if we can talk, if you can explain that to me, I mean, because the ESP is covered, so the integration
No, it's not covered.
is covered because we are using measure boot. So if you change something in the ESP,
Yeah.
this is going to be detected because of measure boot. So any change in the kernel command line, initRD, the bootloader, or any FE binary that is going to be loaded, this is covered.
Yes,
If you say
but
you
it
change,
means, but it means that you detect it after the next boot. Then suddenly you figured, oh, blimey, I can't boot. Which
but this is always
so,
it's
but
not.
if you set things to write protected,
Yeah.
you can't even modify the ESP.
Okay, this is much
So
better.
you'd be covered against that. You still could boot.
That should be done. Yes.
Of course, it's read-only. And who cares about Windows? I thought we were doing Linux here, don't we? And I mean, by all means, so not all drives can do TCG, so take your pick. So right, don't use TCG drives if you want to do Windows, fine. It's an optional feature anyway, because not all drives support it.
But maybe this is a very interesting topic.
Yeah,
So,
I'm not. I sincerely do not agree with that. If you want to have dual boot, by means do dual boot, but don't bother us with that.
we should work on that. At least dig on that because okay.
I'm back. So, second question. At the moment, your policies are based, I believe you're measuring firmware, kernel, bootloader, initRD. That means you have to generate the policy on the machine in order to understand the firmware state. Have you considered not measuring the firmware so the policy can be pre-generated ahead of time and actually updated on the system? So actually sent with the zipper update.
Okay.
And then you could use a private key because you can update. There's a TPM policy allows the policy to be updated if the policy is signed by a known authority. So you could have you considered that so you could then pre-generate the policy and then zip it up. We'll just automatically apply the policy because you can pre-measure the whole thing.
Yeah. I mean, this is
Yes, you wouldn't be measuring the firmware, but you still be able to measure everything else.
Yeah.
And then you have secure boot before that to give you the
Of course.
attestation.
I mean, this is a goal. This is a goal.
That's a goal? That's cool.
But we have a proof of concept of that for the kernel bootloader and the initRD, but the initRD is locally generated. So
Yeah.
But in OBS we can generate initRD can be generated in OBS, can be downloaded, and there is code to do that, and we have a proof of concept.
Yeah,
So-
host only initRD would be if it was the not host only mode initRD, then you would be able to, I assume.
Yeah.
Yes.
I mean, but this is something that we want to go. But
Yeah.
there are considerations because if
Yeah.
we go to the UKI path, this is going
Yes.
to change.
Yeah. Yeah.
Because the UKI is going to be SafeNet, so there is a more
Yes.
easy way to combine secure boot, measure
Yeah.
boot, but still you can deliver the payload that is going to install the prediction in the PCR log
Yes.
file. So yes, we want to go in that direction.
Yeah, 'cause that sounds like a much better experience
that-
rather than having to enter your PIN
yeah,
every single time.
No, you don't enter the. I mean, it's completely transparent for you. So
Yes.
once that is there, one solution or another is going to be transparent. The difference is that the SUSE is going to sign the prediction.
Yes.
That is a much better guarantee. Yes.
Yeah. Yeah. Okay. Cool. That sounds awesome. That sounds like a really good way
Yeah,
of doing
but
it.
it's not easy to do that. But there
No,
is
it's not.
proof-
No, nothing. It involves a TPM. Nothing is easy.
Yeah.
Anyway, thank you.
How would you see device authentication and measurement with things like SPDM fit into this this framework?
We've been talking about this with your engineers. Okay.
Yeah,
So-
I know you've been. I'm asking.
So Damien's engineers have been harassing me about this. The problem with SDDM is that it can't generate an arbitrary signature. It's forced in a certain format, and so the TPM then can't actually do anything with it because the TPM expects a different format. And so SDDM is at the moment too inflexible to work with other cryptographic systems for attestation.
So we have a problem that we need to fix them.
Yes, I have told you.
That's kind of the question.
I have told your engineer. I have told your engineers this about 4 months ago, and they haven't responded. So sorry.
Um,
Can we get me later?
yeah.
So it seems that right now we're talking about openSUSE only. What about the SUSE products? Have you also thought about how this may or may not work with unified core?
We want, I mean, obviously microS is the testing bed, so everything should be working first there, and there are complications that we need to resolve first there. Eventually, this is going to reach. I mean, we are making decisions. The decision is that Group 2 BLS is going to be the default for one distribution, and System deboot is going to be the default for another one. That gives us users that are going to test two bootloaders that are following the BLS. That is going to have a feedback in the installer, a feedback in the tooling, and put that in place that can be used completely transparent in the enterprise side. Actually, we are committing the code. So the same tool that we have in factory, we are making sure that it's also in this SLEFO, whatever is the name today. I don't remember. Yeah, it's less 16. So the code is there. So it's up to the installer to decide if this is going to be activated or not. But we are, I mean, this is the goal, obviously. So it's because we believe that it's a better approach than one based on graph. It's more flexible, it's extremely fast, it's more secure because we don't have memory issues. So that means that the K generation function, we are using the Argon 2, whatever, that is the super cool one that is exhausting completely the memory. So we want to achieve that, but let's break first microS, let's make decisions there, and make sure that everything in the other side is completely synchronized and is a switch, and use that.
So since you mentioned that eventually we want to make GloBLS the default for Tumbleweed and other distributions likely, what is the plan for supporting migration from not all Grob to
Okay,
BLS or system deboot?
this is a very good question. So there are, yeah, the short answer is no, because you need a different partition. So you need a larger partition. This can be resolved. So probably automatically it's not going to be supported, but maybe some documentation is going to appear that is going to explain you how to do that manually. Maybe this is going to happen, and it's a good experiment, and people deserve the effort. I mean, deserve to have the chance to do the effort to do the migration. So automatically no, manually, yeah, it's possible. I did that several times, so it can be done.
So I have a small question. There is a situation where you have to work with disk encryption, even if you don't care about the data security. This is a hibernation of the notebook if secure boot is enabled. Is it planned feature to support that just an
It's
encrypted swap?
Yes, it's supported. So I think that I mentioned that some. Yeah, it's supported. The short answer is these are really for you. You can use that. I use that. So a big swap is going to be encrypted. You can encrypt the root file system and the swap at a different partition. You generate a big one, Ethernet inside that, and system decrypt setup is already taking care of reading the status and using again the policy to validate the status of the system. So this is really, it can be used. Yeah, it's here. Swap encryption. Okay, thank you.